Okay, so we're asked to complete the proof by choosing the rule that justifies each step. So for this problem, we're just filling out this rule column. Okay, so if you look at the first row and the second row to see what's changed, 1 minus sine squared x changed to cosine squared x. So anytime you're, at least for this class, when a trig function being squared changes to another squared trig function, that's the Pythagorean rule. Okay, because we have this rule that sine squared x plus cosine squared x equals 1. If you rearrange this, if you subtract sine squared x from both sides, you get cosine squared x equals 1 minus sine squared x. Okay, so that's they took this Pythagorean identity and rewrote it. So in this next step, from the second row to the third row, what's changed is now that cosecant x is 1 over sine x. And so that is a reciprocal rule, okay? That sine of x, that's equal to 1 over cosecant x. And then the other two pairs are cosine x, that's 1 over secant x. Okay, the reciprocals of one another. So it's a reciprocal rule. And then tangent x, it's the last one, right? 1 over cotangent x. So this rule here is the reciprocal rule. And then look how it was cosine squared x. Now it's just cosine x. There is 2 cosine x's multiplying here. That means cosine squared. So what they did is they just rearranged the problem. You know, the order you multiply, it doesn't matter. You can just do cosine x and then multiply by cosine x and you get cosine squared. So anytime you rearrange without using any of those trig rules that we've done in this course, that is algebra. And then for this last step, now that we've rearranged, we've almost got what we were trying to prove. We've almost got cosine x, cotangent x. So from this second to last row to this last row, you can see that the parentheses was replaced with cotangent x. Okay, so anytime, these are the reciprocals. Anytime you use this fact that tangent x is sine x over cosine x. Cotangent x, that's cosine over sine, because it's the reciprocal tangent, right? Excuse me. So anytime you do that, these are the, actually, I'm blanking on it right now. As the quotient rule is what they want to say. Okay, these two that I just wrote down are the quotient rule. Okay, then you can hit check, and then Alex will check through the rules, make sure they all line up. So let's try another one here. The proof is we're supposed to take this left side, make it equal to this right side. They've done the statement columns for us, so we just have to go untangle all the rules. But cosine squared x, they rewrote that as 1 minus sine squared x. So that's that Pythagorean identity that we just talked about. And then you've got sine squared x minus 2 plus 2. So look what happened. They distributed this negative 2 to the 1. And then distributed negative 2 to negative sine x. So that's not a trig rule. That's just an algebra rule. And then final step was that they have sine squared x plus 2 sine squared x. That makes 3 sine squared x. So again, that's algebra. We're just adding like terms there. Let's do one more. Okay, for the first row to the second row, what they've done is, see, these parentheses are the same, except for a minus sign and a plus sign. So those complement each other nicely, so that if you multiply these two parentheses, the middle terms cancel out, you just get 1 minus sine squared. So that's just algebra. You could practice this yourself. Do 1 times 1, 1 times sine x, negative sine x times 1, and then negative sine x times times positive sine x. And then they said 1 minus sine squared equals cosine squared, so that's the same Pythagorean identity we've seen a couple of times in this video.